Look for lines. Check the angles. Classify by attributes.
Look out across the flooded marsh. From this height, the divided fields, sandbars, and still channels can look like a random collection of borders. Sedge, the heron, wades through these shapes every day, navigating a landscape defined by its edges. To navigate this environment accurately, we need a way to sort and name the distinct flat shapes created by these land borders. We can read these shapes by using a two-step checklist. It relies on evaluating two specific features: the sides and the corners. Step 1 is checking the sides. We look for lines that run alongside each other and never meet, no matter how far they are extended. We identify these as parallel sides. Step 2 is checking the corners. We examine the intersections to see if the sides cross perpendicularly to form a perfectly square 90-degree right angle. Following this checklist provides a reliable way to sort figures into their mathematical categories based on how they are built. This diagram models a real four-sided field to test the first step of our checklist, analyzing opposite sides. The top and bottom borders run parallel, and so do the left and right borders. This means the shape has exactly two distinct pairs of parallel sides. Shifting to step 2, we look at the corners. At every intersection, the sides cross perpendicularly. A square fits neatly into each one, giving us 4 right angles. The combination of exactly 2 pairs of parallel sides and 4 perpendicular corners defines the shape as a rectangle. This next shape is a sandbar with 3 straight sides. Since the 3 lines of a triangle will always eventually meet, we skip the parallel check and move straight to the corners. Applying the corner check, we find one intersection where the sides meet to form a 90-degree angle. The other 2 corners are smaller, but it is that single square intersection that defines the category of this figure. Because this triangle possesses exactly one 90-degree corner, it is classified as a right triangle. In geometry, a single right angle is a powerful enough feature to create an entirely distinct category of triangle. Here we have 2 different slanted fields. Notice that neither shape has a square 90-degree corner. Even without right angles, we can still use the parallel check. In shape A, both sets of opposite sides run parallel to each other. With 2 pairs of parallel sides, shape A is classified as a parallelogram. In shape B, only the top and bottom sides run parallel. The side borders are slanted at angles that would eventually cause them to cross. Because it possesses exactly 1 pair of parallel sides, shape B is categorized as a trapezoid. By simply counting the pairs of parallel sides, we can accurately distinguish between different quadrilaterals, even when they don't have right angles. When we apply these rules, the marsh becomes an organized layout of geometry. Each figure, the rectangle, the right triangle, the parallelogram, and the trapezoid, is defined by its specific properties. To name these flat shapes, check the sides for parallel lines, and check the corners for square right angles. Understanding these properties gives us the vocabulary to sort and name polygons by their mathematical structure. For instance, if you find a 4-sided shape that has exactly 2 pairs of parallel sides, but 0 square corners, what would you call it?
Parallel lines never meet. Right angles stand square. Attributes guide sorting.